Good morning, my dear students. My name is Dr.A.Damodar. I am working as an assistant professor in mechanical engineering department at a JNTU College of Engineering, Pulivendula, which is an constituent college of Jawaharlal Nehru Technological University, Anantapur. I did my B.Tech in mechanical engineering in the year 1999 to 2003 and masters from SK University at G. Pullareddy Engineering College in CAD in the year 2003 to 2005. Later I worked for 4 years in the CAD industry in an MNC company. The name of the company is Infotech Enterprises Limited at Madhapur. I worked on various CAD softwares and CAE softwares, that is computer aided engineering and computer aided design softwares. The CAD softwares majorly I worked on CATIA V5, AutoCAD and CATIA V4. Apart from this, we used to work on PLM solutions also, that is product lifecycle management. I used to work sometimes on the CAE softwares, basically on the meshing softwares, that is finite element methods software, methods I can say, instead of finite element analysis. Before analysis, we used to mesh the component. We will see what is the need of that CAE software in next further classes. So after working for a period of 4 years, I worked. Later I joined in Goharaj Rangaraj Institute of Engineering Technology, which is an affiliated private engineering college, in the year 2009 to 2011. From 2011 February 4th onwards, I am working at JNTU Anantapur University, and I used to mostly teach the mechanical subjects which are related to production engineering side. So before, this is my brief introduction about about me. So today's class in the CAD subject, first I would like to introduce the CAD subject. In this class particularly, we will learn about what is meant by CAD software, what is meant by a CAM software. Apart from this, there is one more software called as a CAE software, that is computer aided engineering. So what is the necessity of CAD software and what is the necessity for CAM software to the present industry? Earlier, this manufacturing, we used to do the prototype, or we used to develop a prototype model. With this model, to prepare this prototype model, there is a huge requirement of technical persons to design the particular product or a particular part. After designing the particular part and product, we need to do the manufacturing before the simulation operation. Nowadays we are having the simulation operations that we can see on the computer screen with the help of softwares. Before 1980s or 1970s, there was no simulation software. Everything need to be done based upon the physical production. Due to this physical production, there is a much loss in the time as well as the huge investment to the companies to see that product and to analyze that product. He need to spend a lot of money. Apart from that, there was, if the product fails, then it is a great loss to the company. For this, the CAD industry, the design industry thought that why can't we produce a product, or why can't we produce a product and visualize the product on the computer, so that it saves the money as well as the production time. So from this, the mechanical engineers also have taken the advantage of this CAD softwares. So at the beginning stage, we used to have only two-dimensional softwares. Later that was extended to 2.5. Later that was extended to the complete three-dimensional softwares. Then with this three-dimensional softwares, again they further extended this software for the analysis work. Next, this softwares are already introduced to the manufacturing of the product also. Even while we can see the manufacturing of particular component in the computer without actual performance on the machinery in the shop floor. So that is the thing. So this was has taken the advantage by the companies, and a large number of softwares are produced in the market. Especially in those days, we used to have the CATIA V4 that is used to work on the Unix and Linux operating system. Later, after the development of the Microsoft operating system, some of the softwares are developed on Microsoft application, that is CATIA, which is more familiar in the aerospace industry because of its advantages of surfacing features. Next is the Pro Engineer software was available. Now this Pro Engineer software was attached to the Unigraphics software. This was later at present these both softwares are purchased by the Siemens company, and they are sometimes they have given that Unigraphics software. But even though both the platforms, the Pro Engineering software and the Unigraphics software was available, and for particularly meshing purpose, the Hypermesh software was used, and for analysis purposes, ANSYS software was used for structural analysis purpose. And whereas when we are going for the thermal engineering or others, CFD, computational fluid dynamics softwares, a large number of CFD softwares and a large number of thermal engineering softwares are also came into the market, and this was used extremely depending upon our requirement. Now we will see what is CAD-CAM. The CAD-CAM is a term which means computer aided design and computer aided manufacturing. So computer aided design software and computer aided manufacturing software. Apart from this, CAD, CADD is also there, that is the computer aided design and drafting software. It is the technology, it is nothing, it is not more than the science, it is the technology concerned with the use of computers to perform certain functions in the design and manufacturing. Already the human being was there, and the technical people who is the person, and he is going to use the technology, that is the various types of softwares on different platforms based on this computers, we are going to work this softwares. It is nothing more, not more than that science. It is the technology. There is a large difference between the science and the technology. Science is the universe which is already having certain theories, but technology was proved from the science. From the science we are going to develop the technology that makes the human being more convenient, comfortable. So CAD can be defined as the use of computer systems to perform certain functions in the design process. We are going to use these computer systems to perform certain functions, definite functions. Means first we are going to develop that, and next we are going to do the simulation operations. So when we see the CATIA B5, there are large number of again this CATIA B5 generally is for part product, next for the simulation purpose, analysis purpose. There will be again vertically it will be divided. So these are all we need to use it in the software. Whereas the CAM is the use of computers, computer systems to either to plan it or manage the manufacturing plant or control the operations of manufacturing plant through direct or indirect computer interface with the plant production resources. Just 1 minute, I will speak and continue the class. చెప్పు సుబ్బాడి.
సార్ రాలేదంటే సార్ ఆయన ఆఫీస్కు ఇంటి దొరకన బ్రేక్ పోయినాను సార్, మరి ఎక్కడ
సరే వస్తే చెప్పు. Next is the, before going to use the computers, there is one process called as a design process. First we need to have an idea. A person need to have the idea. How this idea comes, that is an important thing. So from the based upon the idea, if I have a certain idea, next to develop one product, next I will think that how to produce that product. So once again to produce that product, I need to search for various types of opportunities. Like if I want to produce a pen, first what I will do it, what is the need of that particular pen. Next it comes to in mind how the pen should be there. Next, if the pen is there, then how already there is already a pen available with some other person, how it should be different to me. So this once if I then I need to perform the synthesis operation. Next, analysis. I need to analyze, I need to prove that product. During this analysis stage, I need to optimize my requirement which were defined at problem definition stage. Next, once it was there, then it need to be evaluated. The pen need to be evaluated whether it was achieved the constraints that was defined during the problem statement. Next is I need to present this pen into this market. So at a time I can't really start production. I will give 100 or 200 pieces. Then these 200 pieces need to be used by the customers, and they give feedback. If the feedback is very good, then the same product will be produced. Example, if you take that, there will be certain cars which are introduced into the market. So the people say that it is a failure model. Some people only purchase that particular car. There will be huge demand for one product by the same company. There will be very less demand, or sometimes no one will purchase that product from, even though it was manufactured from the same company. So why this happens? Because it is due to the failure. Some products will be useful based upon the constraint, and some will be failure because of the product disadvantages. So first we will see how this. So first thing is, I need to state the problem. Generally during the research work also, 40% of the research work will be completed if I problem definition stage itself. I need to define the problem, which is the important thing. During the definition of the problem itself, I need how to solve the problem it comes to in mind. Next is I need to state the problem. Suppose if I take this is a pen, how length should be this pen? How what should be the diameter of this pen to hold between the fingers? How smooth should be the edge, and how much quantity of fluid liquid into this pen need to be inserted? How much I can write based upon the fulfillment of the ink? What should be the thickness? Means while writing, some pens write very large and some pens write very thin. How much the thickness of the nib should be there? To all those things that I need to define in the statement of the problem. Once I state the problem, then a large number of ideas will come into a mind. There will be large number of ideas. These ideas will be given by me, by our friends, by reading the newspapers or by reading the journals. All those things comes into the mind. Next is the different ideas will be there to solve a particular problem. Next I need to go for the solution. I need to select among which idea is good, so I select that particular thing. Once I select that particular thing, next I will go for the building the team. I am the team leader. I thought that this idea was good, and if I go in this particular path, I will get the solution. For this, a single person can't be done. Next I need to build the item. Item means what are the requirements to complete those problem that was defined in the statement. Next I need to evaluate that problem, whether this problem was within constraint with the statement or not. And this evaluation and statement of the problem, again and again, if I produce a product, I will check to the definition team, and both the product which was developed is correct or not, that I will always be compared with the statement of the problem. Next I go for the result presentation according to this. So large activities will be happening from the statement of the problem to the presentation of the results. So defining the problem, what should be there? There you can, in this diagram you can able to see the different types of things. Here define the problem, it needs to be assessed, problem statement should be there, design certain design criteria and goal should be there, background research work should be there. Then the generate possible solution, brainstorming, idea trigger method, thumb sketching, thumbnail, sometimes sketching, and creative thinking. If I go how this problem in the universe, to every problem there will be a solution, but the solution may not be there at present. it may be outdated. Again, after certain period of time, again this can be used. For example, if I tell this beautiful example, before the Toyota Innova, there was a Toyota Qualis vehicle which was huge demand in the market in those days. So this Qualis model was developed by the Japan people, and in the year 1970s or 80s, and that was the hit model in that during that period. And later that same model was stopped by that company in Japan, as other competitors are better, and the same Toyota car was introduced in the India in the year 2003 or 4, and it was a huge success in the market during that period of time, because the same model was produced here. So that like that the thing will be there, and evaluate possible solutions. Suppose I am having only 10 rupees, if I want to purchase a 100 rupee product, it becomes a difficult for me because my budget is very low. There will be a biscuits. The biscuit will be for 1 rupee. There will be biscuit for 10 rupees. I can't give 10 rupees biscuit to a beggar, and I can't give 100 rupees. I can't able to purchase 10 rupees biscuit for him. Okay, so I based upon my both are biscuits only, but based upon the criteria to whom. If I give 1 rupee biscuit to an IAS officer, he will throw at me. If I give the same 1 rupee biscuit to a beggar, he feels more happy. So different criteria will be there. So we need to evaluate what should be the possible solution. For this possible solution, and again make and test a model with the help of detailed technical drawings, with the help of prototype or scale model, and mathematical and computer models, and performance and user tests. And I need to modify and improve the design. So there should be a continuous modification in the design what we have developing or developed, and it should be refined for many times to get the fixed one. So once if at a time I can't develop a model, first I will develop some model, and when I use it, then I need to solve some of the problems which were developed from it, and again the improvement can be taken place, and do more testing. Again it need to be, in the worst case I need to scrap it. A best example is the phones which we will be using. First they will introduce one new software. Software means one app we are going to develop it, and later after introduction sometimes there will be big bug fixes which the app will not be perform. So they go for the updation to fix that problems. Once the problem was fixed, then they will develop the design. Then they will give some more importance to the development. What I mean to say, graphical interfaces they may develop it, and again they will test it, and if they test it and more people are using it, so it is a competitive world, and after a period of certain time this app they stop using it due to less development interfaces to the human being. So once if it was less human face interface, in the worst case we need to scrap it. Suppose nowadays if I can, it depends upon the human mentality again. If I use this same phone, it will be happy to me, but whereas my kid who will be in advanced stage, she will not use it or he will not use it. So again we need to scrap it. There should be a continuous development upon each product we develop, because human being nature, human mind nature will be always looks for the comfortable in and easiest way to a problem or the solution. Next is the communicate the final design. Once my product was good, then I will start preparing the designs. Will be the final technical drawings. These drawings will be having a technical manuals for assembly and operation and the maintenance. So this is the process. Next is the design process. What is meant by a design process? Engineering designers require effective means of collecting, storing, retrieving, processing, communicating, distributing, displaying, plotting, printing large quantities of information. So the designers, what they are going to is, effective engineering designers, they used to collect it, the data. They need to store that particular data or the design what you have developed. You need to retrieve the data whenever there was a requirement. We need to process the same data. We need to communicate the same data, and we need to distribute it to different people, and we need to display the data based on it. Sometimes we go for the plotting, means if the drawing is very big, then we need to go for the plotter, and sometimes we go for the printing in a large quantities for information. So what the mechanical engineers do is, in the manufacturing, once we develop a particular product or part, the part need to be shown in terms of the drawing on the engineering graphic sheet. In the graphic sheet. So how, again, that's why we introduced the subject engineering graphics and in the first year, and mechanical drawings in the third year. So why the important thing is how best we represent our ideas in the theoretical form to the drawing form. So engineering graphics is nothing but a language. So the model of the design. To every design problem, there corresponds in principles an infinite number of solutions. So where P1 is the current design problem, TS is the creation of a number of tentative solutions to this particular problem P1, whereas EV is the evaluation of tentative solutions, and P2 is a corrective solution to the problem. So there is a particular problem P1. To this problem, there will be a tentative solutions to this problem, to this particular problem. For this, the evaluation will be there for the tentative solutions, and finally we are going to produce the P2 correct solution to this problem. That means first I am having a problem. I will give a 5 to 6 tentative solutions to my problem, and in this I will choose one solution, and after doing certain experiments I will give the correct solution to that particular problem, and I will tell to others. Suppose how this problem will be in general words. Suppose I want to go from this place to other place. I will ask someone how to go that place. Someone will say that car, someone will say that bus, someone will say that train, someone will say that ship, all those ways. Then from these temporary solutions, I will choose the one of the best whether how to reach my particular location with cheapest cost and comfortable. Then this is, you can term it as effective solution from the tentative solution. Finally, I will reach that place, either bus or car, whatever it may be, in optimal mode, and I will prove that that is the solution for this problem, and I will ask the remaining people to use this particular solution for this problem. So, this problem need to be kept in the design form or in the paper form. Next, in the role of computers in the design process. So, that we will see in the next class. By this, I will end for this today's session, and after a period of 1 hour gap, I will tell you the role of computers in the design process. Thank you for today's hearing. Hope that this class will be useful basically for the final year students or third year students. I need to tell you one thing about this CAD/CAM subject. In the year 2003, when we are studying, when I am in the final year of engineering, this CAD/CAM is an elective subject. And as always the other fields are developing, this CAD/CAM subject first it became the regular subject in a course curriculum for final year. Next, they have introduced this subject in the third year itself. So there is a continuous improvement in the syllabus also, and once the syllabus was very less, now the syllabus became very vast. Okay, so anyway, this is one of the things which I need to tell, and in the next class we will discuss about the role of computers in the design process, and what are the definitions of the CAD tools, what is the definition of the CAM tools, and what are the applications of this CAM subject, and how these CAM tools are defined, and what is meant by the CAM tools required to support the design system and product cycle in a conventional manufacturing environment. So by this today I will end for this session. In the next class I will discuss about role of computers in the design process. Thank you.